A 2,000-year-old device predicts solar eclipses with gearwork rivaling a modern clock. This video explores 20 ancient technologies that scientists still cannot replicate, revealing a forgotten chapter of human genius. By the end, you will see history not as a slow march forward, but as a story filled with astonishing leaps and mysterious dead ends. How did a civilization without steel cut granite with machine-like precision? And why does Roman concrete last longer than our own? Each artifact we examine is a direct challenge to our understanding of progress. What does it mean when the past appears more advanced than our present? The true challenge of these objects lies not in their age, but in their defiance. To stand before a 2,000-year-old artifact and feel a sense of technological awe is to encounter what researchers call an out-of-place artifact. This is not simply an old tool or a clever invention. An out-of-place artifact demonstrates a level of precision, a mastery of material science, or a conceptual leap that seems to belong to a different era entirely, as if a piece of a more advanced timeline was accidentally dropped into our own. It creates a silent tension in museums and laboratories, a puzzle that resists the neat story of linear human progress. Were these incredible objects the result of a lone, forgotten genius whose insights died with them? Could they be fragments of a broader, more sophisticated culture that was lost to time, its knowledge scattered like pages from a burnt book? Or do they force us to reconsider the very definition of primitive? This foundational mystery is the lens through which we must view each entry on our list. It transforms a simple catalogue of old things into a detective story about human capability itself, reminding us that the past holds whispers of ingenuity we are only just beginning to hear. Our journey begins not in a laboratory but at the bottom of the sea. In the year 1900, sponge divers working near the Greek island of Antikythera stumbled upon a Roman-era shipwreck, a treasure trove of statues and artifacts. Among the recovered bronze and marble was a lump of heavily corroded gearwork, so encrusted it was initially set aside as a curiosity. Decades later, painstaking cleaning and modern imaging techniques like X-rays would reveal its true nature, and the scientific world would collectively gasp. This was the Antikythera Mechanism, a device so advanced it rewrote our understanding of ancient Greek science. Here was a hand-powered, geared computer from over 2,000 years ago, designed not for simple counting, but for modeling the cosmos itself. Its complexity is breathtaking. The original device, housed in a wooden case roughly the size of a large shoebox, contained at least 30 precision-cut bronze gears. By turning a hand crank on the side, an operator could align a series of dials and pointers to calculate the positions of the sun, the moon, and likely the 5 known planets. It could predict solar and lunar eclipses years in advance, not as mystical omens, but as calculable astronomical events. One dial even tracked the 4-year cycle of the ancient Olympic Games, tying celestial time to human culture. This was not a toy or a speculative model. It was a practical instrument of remarkable accuracy, a portable planetarium built with technology we thought belonged to the Renaissance. The central mystery, and why it tops our list, is not just what it did but how it was conceived. To build such a mechanism required a fusion of knowledge that seems impossibly ahead of its time. The designer needed a sophisticated understanding of Babylonian astronomical cycles, Greek geometrical theories, and precision metalworking. The gears feature teeth cut at precise angles to create specific mathematical ratios, translating celestial motions into mechanical rotation. Modern engineers using computer-aided design and advanced machining have struggled to create fully functional replicas. This single artifact implies a lost tradition of high craftsmanship and theoretical mechanics in the Hellenistic world, a school of thought that simply vanishes from the historical record after this ship sank. Its silent, corroded gears ask us a profound question. If this is what one Greek workshop could produce, what other marvels of that lost technological lineage were built, used, and ultimately forgotten, leaving no trace but this one salvaged wonder? From the intricate clockwork of the stars, we move to the art of the forge, where fire and iron were woven into legend. The swords of Damascus were not merely weapons, they were spoken of with a reverence bordering on myth. Warriors and kings believed these blades could slice a falling silk scarf in midair and remain sharp enough to cleave through a rifle barrel. Their most famous feature was a mesmerizing, watery pattern on the steel, like a frozen stream rippling across the metal. This beauty, however, was a byproduct of a strength and sharpness that modern science struggles to equal. The secret began far from Damascus, with lumps of raw material called wootz steel, imported from ancient India. This was a high-carbon steel, but its potential was locked away, a puzzle only a specific and now lost forging process could solve. Medieval smiths in the Middle East discovered that through a meticulous ritual of heating, folding, hammering, and cooling at precise, guarded temperatures, they could unlock the steel's legendary properties. The result was a blade of paradoxical qualities, both incredibly hard to hold a razor edge, yet flexible enough to bend without snapping. For centuries, this was the pinnacle of metallurgy, a technology that gave its wielders a terrifying advantage. The central mystery is not the material but the transformative art. Modern metallurgists using electron microscopes have peered into the very structure of ancient Damascus steel. They found something astonishing: carbon nanotubes, tiny, incredibly strong structures woven into the metal itself. These nanotubes are a product of the specific impurities in the wootz ore and the unique thermal cycling of the medieval process, a kind of accidental nanotechnology achieved over 800 years ago. While today's blacksmiths can create beautiful pattern-welded steel that mimics the look, and while our industrial alloys are strong in different ways, no one has consistently recreated the exact alchemy that produced the original combination of that flowing pattern, that legendary sharpness, and that supernatural resilience. The knowledge was not written down in manuals, it resided in the hands, eyes, and instincts of master smiths, passed from teacher to apprentice in the glow of the forge. When that chain of craftsmanship was broken, the full recipe vanished. So we are left with a profound irony. We can analyze the steel with atom-level precision. We can identify the very nanostructures that give it strength, yet we cannot reliably command the fire to make it anew. It stands as a testament to a form of knowledge that existed not just in the mind, but in the rhythm of the hammer and the color of the heat, a seamless fusion of material science and art that elevated a simple tool into a whispered legend. That same mastery of materials is found not in a blade but in a building. Walk into the Pantheon in Rome and look up. The dome that arches over you was poured from concrete nearly 2,000 years ago, and it remains the world's largest unreinforced concrete dome, a silent, enduring marvel. Meanwhile, modern concrete bridges, parking garages, and seawalls often show worrying signs of decay after just 50 years. This stark contrast points to one of history's most humbling engineering puzzles. Roman concrete does not just endure time, it seems to collaborate with it, growing stronger where our own mixtures fail spectacularly. Their secret was not in complex machinery, but in a revolutionary recipe and a profound understanding of chemistry that we are only now beginning to fully appreciate. The Romans mixed lime, volcanic ash from regions like Pozzuoli, chunks of rock, and a surprising key ingredient, seawater. This was not a mistake. When seawater permeates modern concrete, it corrodes the steel reinforcement inside, causing it to crack and spall. But for the Romans, seawater was the catalyst for magic. The combination of lime and the specific volcanic ash, called pozzolana, creates a rare chemical reaction when exposed to salt water. Over centuries, seawater filtering through the concrete actually promotes the growth of rare minerals like aluminous tobamorite, forming interlocking crystals that fill in micro cracks. In essence, Roman concrete possesses a form of self-healing. Where a tiny fracture begins, chemistry steps in to seal it shut, a process that continues for generations. Modern scientists, using advanced tools like electron microscopes, have mapped this crystalline structure, decoding the why behind its longevity. Yet knowing the blueprint is not the same as possessing the craft. The central challenge today is one of replication and scale. We can create small laboratory samples that mimic the ancient concrete's properties, but doing so consistently, affordably, and in the massive quantities needed for modern infrastructure remains an enormous hurdle. The Roman formula was not uniform. It varied by region and purpose, relying on locally sourced materials with unique chemical profiles. More importantly, its greatest strength, its millennia-long curing process, is a timescale utterly incompatible with contemporary construction demands. We build for decades, they built for eternity. So the Pantheon stands not just as a monument to architectural ambition, but as a quiet, persistent question from the past. It asks us if our pursuit of faster and cheaper has come at the cost of building things that truly last. Each crack that fails to appear in its ancient dome is a testament to a forgotten philosophy of construction, where the goal was not merely to build for the present, but to engineer a legacy for the distant future. The sheer physicality of Roman concrete is rivaled only by the silent, staggering mass of stone. High in the Andes, overlooking the ancient Inca capital of Cusco, stands Sacsayhuaman. This is not a fortress built, but one that seems to have grown from the earth itself. Its defining feature is a series of 3 zigzagging walls, constructed from limestone blocks so enormous they defy belief. Some weigh over 200 tons, equivalent to a herd of 35 adult elephants. Yet their size is not the true mystery, it is their fit. These are not simple rectangles. Each stone is a unique, irregular polygon with multiple complex angles and faces. They were shaped and placed against one another with a precision that borders on the impossible. The joints are so tight, so flawless, that even today you cannot slip a razor blade, a piece of paper, or even a human hair between them. This was achieved without a single drop of mortar, without iron tools to cut the rock, and without the wheel to transport it. The walls form a monumental, 3-dimensional jigsaw puzzle that has survived devastating earthquakes for centuries, each tremor only settling the stones more firmly into their eternal embrace. How was such a feat accomplished? The theories are as bold as the architecture itself. Some suggest the Inca possessed knowledge of a plant-based liquid that could temporarily soften stone, allowing them to mold it like clay. Others point to legends of sonic levitation, where specific sound frequencies made the massive blocks weightless, guided into place by chanting workers. More conventional explanations involve meticulous pounding with harder stones, thermal fracturing using fire and water, and an unimaginable amount of patient labor using ropes, ramps, and log rollers. Yet each theory hits a wall of its own. Modern experiments using these proposed techniques have managed to shape smaller stones with rough approximations, but none have come close to replicating the scale, the precision, or the seamless complexity of Sacsayhuaman's largest blocks. The process remains a profound gap in our understanding. This suggests the Inca masons operated with a different kind of knowledge, a deep, intuitive mastery of geometry, leverage, and material behavior that was passed down through generations of practice, not written formulas. They did not force the stone to conform to a plan. They understood each individual block so completely they could find its one perfect place in the greater whole. The result is more than a wall. It is a testament to a philosophy where architecture is a conversation with the landscape, a bonding of immense weight and delicate precision that has left a puzzle for the ages, etched in stone and silence. While the walls of Sacsayhuaman speak of immense weight and perfect fit, another ancient technology whispers of a different kind of perfection, one measured not in stone but in steel. Scattered across northern Europe, pulled from the resting places of Norse warriors, are swords that bear a name. Etched into their blades is the inscription plus Ulfberht, a mark that transformed a simple weapon into a legend of its age. These are the Ulfberht swords, and to hold one was to wield a piece of the future. For centuries, they were thought to be fine examples of Viking craftsmanship, but modern science has revealed a truth far more startling. When metallurgists subjected these blades to analysis, they discovered something that should not have existed in Europe for another 800 years. The steel was not the typical, uneven, slag-riddled iron of the Viking Age. It was crucible steel, a material of astonishing purity and consistency. Its carbon content was remarkably even throughout the blade, and it contained almost none of the brittle impurities that made other swords prone to shattering in battle. This level of quality, this mastery of high-carbon steel, was not seen again on the continent until the furnaces of the Industrial Revolution began to roar. The mystery is profound and twofold. First, the material itself. To create steel this pure requires heating iron ore to temperatures exceeding 1,200 degrees Celsius, a white-hot heat that Viking-era bloomery furnaces, which typically reached only about 1,100 degrees, could not reliably achieve. This has led researchers to a fascinating possibility: trade. The closest known source for such high-quality crucible steel at the time was in Central Asia, in modern-day Iran and Afghanistan. Did daring Norse traders voyage down the river systems of Eastern Europe, connecting to the Silk Road to acquire these prized steel ingots, a raw material more valuable than silver? Or did they somehow acquire the knowledge to make it themselves, a technological secret that was later lost? The second mystery is the inscription. Ulfberht was not a common name, but a brand, and its consistent use over 2 centuries suggests a workshop or a guild that maintained an incredibly high standard. A warrior who owned such a sword possessed a colossal advantage. In the chaos of a shield wall, where most blades would bend or notch against armor, an Ulfberht would hold its edge, its flexibility allowing it to absorb brutal impacts without breaking. It was, in essence, a superweapon. Yet, like the secret of Damascus steel, this knowledge vanished. The supply of pure steel ingots may have been cut off by shifting trade routes, or the master smiths who knew how to work the material took their secrets to their graves. The Ulfberhts that remain are more than artifacts. They are silent markers of a brief, brilliant window where the Norse world connected to global networks of technology and trade, producing objects of such refined quality that they stand as lonely peaks in the archaeological record, waiting for history to catch up. The legend of the Ulfberht sword is a mystery of metallurgy, of purity forged in secret. But the next technology on our list represents a different kind of power altogether, one that was not wielded in silence, but unleashed with terrifying spectacle upon the sea. For the sailors of rival empires, the most dreaded sight was not an enemy fleet, but the glow of an unnatural flame on the horizon. This was Greek fire, the ultimate naval weapon of the Byzantine Empire, and its secrets were guarded more fiercely than any treasure. From the 7th century onward, this incendiary substance became the empire's most potent shield, a technological advantage that preserved Constantinople against sieges for centuries. Historical accounts describe a nightmare-made liquid. When pumped through bronze tubes mounted on Byzantine warships, it would erupt in a roaring jet, a stream of fire that did not simply burn but clung to whatever it touched. Most horrifying of all, it burned even on water, turning the sea itself into a sheet of flame around enemy vessels. Sailors who tried to douse it with water found the flames only intensified, spreading the inferno. Sand and vinegar were said to be the only ways to smother it, knowledge that often came too late. The psychological impact was as devastating as the physical damage. To face it was to face a weapon that seemed to defy the very laws of nature, a tool of what appeared to be divine favor for the Byzantine emperors. The core of the mystery is not its use but its recipe. The exact composition of Greek fire was the most closely held state secret of its age. Knowledge was compartmentalized, with different families or guilds responsible for separate ingredients or processes, and the final formula was known only to a select few, perhaps even only the emperor and one trusted alchemist. This secrecy was so absolute that when the Byzantine Empire finally fell, the knowledge vanished with it. Modern chemists and historians have pieced together plausible hypotheses from fragmented descriptions. The base was likely a form of crude oil or naphtha, similar to modern gasoline, which would explain its ability to float and burn on water. To this, they may have added pine resin for adhesiveness, making it stick to ships and sailors. The most puzzling ingredient is the one that gave it its self-igniting and water-resistant properties. Some suggest quicklime, which heats violently when mixed with water. Others propose white phosphorus or certain sulfur compounds that ignite on contact with air. Yet every attempted recreation, while producing a fearsome incendiary, falls short of the legendary accounts. None have perfectly replicated the reported combination of being easily projected, fiercely adhesive, water-igniting, and nearly inextinguishable with ordinary means. The true formula was likely a precise alchemy of ingredients sourced from specific regions, combined in a specific order with a specific process, a piece of chemical engineering that was lost forever. Greek fire stands as a stark reminder that technological supremacy can be as fragile as the parchment it is written on. It was a weapon that shaped the fate of nations, only to become a ghost in the historical record. A literal flash of brilliant, terrifying genius that we can describe in awe, but can no longer hold in our hands. A weapon of fire is a terrifying force of nature made manifest, but the next artifact on our list hints at a different, quieter form of power, one that flows invisibly and would not be harnessed for common use for nearly 2 millennia. In the basement of the National Museum of Iraq sits a small, unassuming clay jar about the size of a man's fist. It was unearthed in the 1930s near Baghdad, and its components are simple: a ceramic pot, a copper cylinder sealed with asphalt, and an iron rod suspended inside. To a casual observer, it looks like a curious storage vessel, but to a modern scientist, it bears an uncanny and provocative resemblance to a basic electric cell. If this jar, dating from the Parthian or Sasanian period around 2,000 years ago, was filled with an acidic liquid like vinegar or grape juice, something remarkable happens. The acidic electrolyte would react with the dissimilar metals, the iron and the copper, creating a small but measurable flow of electricity, around 1 volt. This is the principle of a galvanic cell, the foundational concept behind every battery in our world today. The startling implication is that someone, over 2,000 years ago, may have understood and utilized this chemical reaction long before Alessandro Volta invented the modern battery in the year 1800. The mystery of the Baghdad Battery is not in its construction, which we can easily replicate, but in its purpose. What was this small spark of electricity used for? The theories are as fascinating as they are contentious. Some researchers propose a practical application in early electroplating, suggesting the current could have been used to deposit a thin layer of gold or silver onto objects for decoration, a process known in ancient Mesopotamia. Others imagine a more mystical purpose, perhaps using the mild tingling sensation from the cell in religious ceremonies or healing rituals. creating a sense of divine power for temple priests. Skeptics offer a more mundane explanation, that it was simply a secure storage scroll holder, with the iron rod acting as a core for a rolled-up parchment, and the asphalt seal keeping out moisture. Yet this does not explain why the choice of metals would create a deliberate electrochemical pair, or why multiple similar jars have been found. The core of the controversy lies in the gap between capability and confirmed intent. We know it can generate electricity. We have no definitive archaeological context, no ancient manual, no depicted scene that shows it being used for that purpose. Modern scientists can and have built working replicas proving the concept functions, but proving a widespread, understood technological application in the ancient world remains elusive. This tiny clay pot thus becomes a profound philosophical puzzle. It represents a spark of potential, a flicker of knowledge that seems to wink at us from across the centuries. Was it a forgotten tool, a prototype for a technology whose development was abandoned? Or was it a happy accident, a curiosity whose true significance was never realized by its makers? The Baghdad Battery forces us to confront a subtle but powerful idea, that the discovery of a principle does not guarantee its application. It stands as a silent testament to a path not taken, a whisper of electricity in a world lit by flame, leaving us to wonder what other quiet potentials from the past remain buried, waiting for the right mind to recognize their charge. Deep in the humid jungles of Costa Rica, a different kind of precision lies half buried in the earth. They are not towering walls or intricate mechanisms, but silent, perfect forms. The stone spheres of the Diquis Delta are an archaeological phenomenon that defies simple explanation. Scattered across the landscape, often in deliberate alignments, are hundreds of these spheres, carved from a hard, volcanic rock called granodiorite. Their sizes range from that of a melon to colossal orbs over 6 feet in diameter, weighing as much as 16 tons. It is not their existence that is so baffling, but their form. Against all expectation for a pre-Columbian culture without metal tools or the wheel, these stones exhibit a near-perfect sphericity. How does a society, using only stone hammers and abrasives, achieve such flawless geometry on such an immense scale? The challenge begins at the very source. The granodiorite boulders had to be quarried from riverbeds or cliffs, a Herculean task in itself. Then came the shaping. The prevailing theory suggests workers painstakingly pecked away at the raw stone with other, harder rocks, then ground the surface smooth using sand and water over what must have been generations of patient labor. This process could, in theory, produce a sphere, but to produce hundreds of them with such consistent precision, to maintain that perfect curve across a surface wider than a person is tall, implies a level of geometric knowledge and quality control that stumps modern engineers. Today, a master sculptor with diamond-tipped tools and precise measuring devices could replicate the shape, yet we have no clear evidence of the jigs, templates, or measuring systems the Diquis people must have used. There are no surviving tool marks that reveal their exact technique, no abandoned workshops with half-finished spheres to show their process. The stones simply appear in the landscape, polished to a smooth, enigmatic finish. Their purpose is another layer of the mystery. Some were found arranged in lines or geometric patterns, leading to theories they were astronomical markers, territorial symbols of powerful chiefs, or representations of celestial bodies in a long-forgotten cosmology. The most haunting possibility is that their true significance was not in their individual meaning, but in the act of their creation itself. The decades-long labor required for a single large sphere would have bound a community together in a shared, monumental project. The sphere and shape of perfect symmetry and balance may have been a physical manifestation of social harmony, a permanent anchor for cultural identity placed in the earth. When the Spanish arrived, the Diquis culture had already faded, and the spheres were left to the jungle, their makers taking the secrets of their craft with them. They remain as silent, polished sentinels, a testament not to a technology of conquest, but to one of profound communal focus, an enduring puzzle of why a society would invest centuries of effort into perfecting the shape of a stone, only to leave them behind as their final, wordless statement. The silent, perfect spheres of Costa Rica represent a mastery of form, a triumph of geometry over stone. Yet another ancient object demonstrates a different, more intimate kind of mastery, a victory not over shape but over time itself. In the Qut complex in Delhi, India, stands a column that seems to defy a fundamental law of nature. The Iron Pillar of Delhi, erected over 1600 years ago during the 4th century, reaches 23 feet toward the sky. It is not its height that astounds, but its skin. In a world where exposed iron rusts within years, this massive pillar, weighing over 6 tons, shows only the faintest, most beautiful patina. It has withstood monsoons, scorching heat, and centuries of pollution without succumbing to the corrosive decay that claims every other piece of ferrous metal. This is not a modern stainless steel alloy, but pure, ancient wrought iron, and its endurance is a quiet marvel of forgotten metallurgy. For generations, its rustless nature was attributed to divine blessing or legendary skill. Modern science has peeled back the first layer of the mystery, revealing a sophisticated chemical recipe. Analysis shows the pillar is forged from remarkably pure iron with a specific, deliberate imbalance. It possesses a high phosphorus content and an extremely low sulfur content. This precise chemistry is the key. When the high phosphorus iron is exposed to air, it does not form the flaky, destructive rust we know. Instead, it develops an astonishingly thin, even protective film called a passive layer, a shield only microns thick that bonds to the metal and halts further corrosion. Delhi's relatively dry climate assists this process, but the true genius lies in the original recipe. The ancient Indian smiths, using furnaces called bloomeries, achieved this specific composition through a smelting process we no longer practice. They used high phosphorus iron ore and a unique method of hammering and folding the hot metal that drove out sulfur impurities while retaining the protective phosphorus. It was a delicate balance of art and science, achieved at a scale that humbles modern engineers. We understand the chemistry in our laboratories. We can create small samples with similar properties. But the profound challenge lies in the pillar's physical reality as a single, massive structural object. To forge such a large column with that exact, uniform composition throughout its entire volume, using the tools and methods of the 4th century, is a feat we have not replicated. The knowledge was not in a formula, but in the sensory experience of the forge, the color of the flame, the sound of the hammer, and the intuition of the smith, passed down through generations until that chain was broken. The pillar stands not merely as an object, but as a testament to a holistic understanding of material, where the process of creation was inseparable from the goal of eternity. It asks us a subtle question about our own relationship with the things we build, whether our pursuit of speed and volume has cost us the patience, the specific craft required to make something truly, quietly permanent. The Iron Pillar of Delhi stands as a monument to physical endurance, a victory over decay. But what of a victory over understanding itself? In the quiet of Yale University's Voynich Rare Book Library rests an object that represents the opposite, a deliberate and magnificent wall of mystery. This is the Voynich Manuscript, a book that has consumed the brightest minds in cryptography, linguistics, and history for over a century, and it remains stubbornly, beautifully silent. Created in the 15th century, this 240-page vellum codex is a work of profound and baffling artistry. Its pages are a riot of delicate, colorful illustrations depicting plants that have never grown on Earth, celestial charts of unknown constellations, and intricate diagrams of what appear to be biological systems, all populated by tiny, naked female figures bathing in strange, interconnected pools. Yet the images are only half the puzzle, accompanying every illustration flowing in neat paragraphs and labels is a script unlike any other on the planet. It is a flowing, elegant alphabet of around 25 distinct characters, written with a confident, fluid hand from start to finish. This is not random scribbling. Statistical analysis reveals a complex internal structure with word lengths, character frequencies, and syntactic patterns that mirror those of a genuine human language. It possesses the consistency of a real, functional writing system, and that is what makes its silence so deafening. For all its apparent logic, no one has ever convincingly deciphered a single word. Not medieval scholars, not Renaissance alchemists, not the codebreakers who cracked the Nazi Enigma machine, and not the most powerful supercomputers of our digital age, which have run endless algorithmic assaults on its text. Every proposed solution, from a simple cipher to a lost Asian dialect to an elaborate hoax, collapses under scrutiny. The plants do not match any known herbals. The astronomy charts do not map to our skies. The text resists every known method of cryptanalysis, standing as a fortress of ink and vellum that has repelled the entire history of code-breaking. The true technology here is not a machine, but a cognitive one, the process of creating an entirely new, coherent, and lengthy linguistic system from nothing. To replicate that today is impossible, not because we lack the intelligence, but because our minds are anchored in known languages and shared cultural references. Creating a script that is internally consistent yet externally meaningless for over 200 pages without a single slip or repetition that gives away its key is an act of mental architecture we cannot fathom. Was it an encrypted repository of heretical scientific knowledge, a constructed language for a secret society, an elaborate mental exercise by a lonely genius, or an artful deception meant to confound a wealthy patron? We do not know. The Voynich Manuscript, therefore, is more than a puzzle, it is a mirror. Its enduring mystery reflects the limits of our own understanding, a reminder that the human mind is capable of crafting boxes that even future generations, with all their tools, may never be able to open. It is a testament not to what was lost, but to what was deliberately placed just beyond our reach, a whisper in a language we may never learn to hear. A fortress of ink and vellum stands in silent defiance, its language a locked door. Yet other ancient creators chose a different, more monumental canvas, one not meant to be held in the hand, but seen by the sky itself. Far from the humid libraries, on the stark, wind-scoured plains of southern Peru, lies a mystery written on the floor of the world. The Nazca Lines are not artifacts you can touch, but landscapes you must step back from to truly see. Etched into the dark desert pavement over 2,000 years ago, these are geoglyphs, giant drawings made by removing the reddish surface stones to reveal the lighter earth beneath. From the ground, they appear as shallow grooves, a confusing network of paths and trenches. But ascend to the height of a nearby hill, or better yet, take flight, and the desert floor transforms. What seemed random resolves into breathtaking, precise forms. Straight lines run arrows straight for miles, cutting across valleys and over hills with unerring accuracy. Geometric shapes, perfect triangles and trapezoids, sprawl across the terrain, and most astonishing of all are the biomorphs, the giant figures of animals and plants. A hummingbird, its wings and long beak perfectly proportioned, stretches over 300 feet. A spider with one leg elegantly extended measures 150 feet across. A monkey with a spiraling tail, a condor with vast outstretched wings, a strange humanoid figure nicknamed the astronaut, all drawn on a scale that seems to belong to the gods, not to people. The central technological marvel is one of perspective and precision. The Nazca people created these immense, flawless designs without the ability to fly, without drones or aircraft to check their work. How did they scale up a small sketch into a perfect figure over 1,000 feet long, maintaining its proportions across the uneven desert floor. The prevailing theory involves sophisticated low-tech surveying. They likely used a system of stakes and ropes, establishing a central axis line, and then using measured offsets to plot key points of the figure, essentially creating a giant grid transferred from a smaller model. By clearing the stones along these plotted lines, they could create the outlines. Maintaining those straight lines over miles of rough terrain, however, is another level of genius. Researchers suggest they may have used a series of aligned posts or smoke signals to keep their bearings, a form of rudimentary theodolite. The sheer logistical coordination is staggering, requiring a large, organized community working with a shared vision over generations. Modern teams, using these same simple tools and careful planning, have successfully created new geoglyphs, proving the basic technique is sound. Yet this practical explanation only deepens the core mystery. It answers the how but not the why. Why invest such colossal effort into art that you, the creator, could never fully see? The purpose remains the true, unreplicated secret. Some theories suggest astronomical alignments, with lines pointing to solstice sunrises or important stars. Others propose they were sacred pathways for ritual processions, walked by priests to communicate with deities. The most compelling idea is that they were meant precisely for the viewers they seemingly imply, beings in the sky. Not aliens, but the gods of the Nazca world, who they believed dwelled in the mountains and the heavens. The lines and figures could have been immense offerings, prayers etched into the earth itself, visible only to those celestial powers looking down. This transforms the lines from mere drawings into a profound cultural act, a technology of faith and communication. The knowledge that is lost is not just the surveying method, but the complete spiritual and social framework that made such a monumental, ephemeral project not just possible, but essential. We can replicate the lines, but we cannot replicate the world that breathed meaning into them, a society that saw the desert not as a barren place, but as a living parchment for a dialogue with the divine. The desert floor of Nazca presents a mystery of scale, an art meant for a viewer high above. But some artifacts seem to hold a mystery within their very substance, an enigma of material and intent that blurs the line between ancient legend and modern creation. Few objects have captured the popular imagination like the crystal skulls. Immortalized by adventure films, these hauntingly beautiful carvings, often of life-sized human skulls made from clear or milky quartz, have long been presented as relics of lost Mesoamerican civilizations, holding secrets of Atlantis or extraterrestrial wisdom. The romantic allure is powerful, a tangible connection to a mystical past. Yet when these objects are subjected to the cold, precise gaze of modern science, a more complicated, and in some ways more fascinating, story emerges. The most famous skulls, like the Mitchell-Hedges skull or those held by major museums, have been meticulously examined under high-powered microscopes. The findings are conclusive and disruptive. The fine, symmetrical grooves and perfectly circular drill holes visible in their surfaces show tool marks that are unmistakably consistent with 19th-century jewelers' equipment, specifically rotary wheels embedded with abrasives like diamond or corundum. These are technologies the Maya or Aztecs simply did not possess. The evidence strongly suggests that most of the renowned crystal skulls were crafted in Europe, likely in Germany's Idar-Oberstein region, a famous center for gem carving during the 1800s. They were probably sold as exotic curiosities to a burgeoning market fascinated by archaeology and the occult. This seems to solve the mystery, labeling them as clever forgeries. But the story does not end there. A stubborn, tantalizing technical paradox remains, one that keeps the debate alive in certain circles. It is claimed by some researchers, even those skeptical of an ancient origin, that a few of these skulls exhibit a peculiar and nearly impossible feature. Quartz crystal has a natural grain much like wood, carving with the grain along its crystalline axis, is difficult but manageable with patient abrasion. Carving directly against that grain, however, is a recipe for catastrophic failure, as the internal stresses cause the brittle stone to fracture and shatter into pieces. The assertion is that sections of certain skulls appear to have been carved against this natural axis. If true, this presents a monumental technical hurdle. Even with our advanced diamond-tipped rotary tools and computer-guided precision, deliberately carving a complex, curved shape like a skull against the grain of a large quartz block is an immensely challenging, delicate, and costly endeavor with a very high probability of ruin. So we are left with a fascinating logical standoff. If the skulls are ancient, as legend claims, then their creators possessed a lapidary technology for working quartz that is utterly absent from the archaeological record and defies our understanding of their capabilities. If they are modern 19th century creations, as the tool marks indicate, then the anonymous European carvers who made them achieved a feat of gem cutting so difficult and risk-laden that it remains a remarkable, hard-to-replicate achievement even today. This paradox transforms the crystal skulls from simple artifacts into a different kind of mystery. They become a mirror for our own desires, reflecting our longing to find impossible technology in the past, while simultaneously showcasing the extraordinary, often forgotten skill of more recent artisans. Their true lesson may not be about lost civilizations, but about the human capacity for wonder itself, and how the line between an ingenious fake and a genuine marvel can sometimes be as clear and as fragile as crystal. Far from the crystal clarity of a museum case, a different kind of mystery lies half hidden in the damp forests of New England. Here, tucked into hillsides and concealed by centuries of leaf litter, are structures that whisper of a forgotten past. Scattered across the northeastern United States from Vermont to Massachusetts are hundreds of stone chambers. To the untrained eye, they might resemble colonial root cellars, the pragmatic work of early settlers. But step inside one and the feeling shifts dramatically. The architecture tells a different story. These are not simple stacked stone boxes. Many feature a distinctive, ancient building technique known as corbelling. The walls are constructed of flat stones, each layer set slightly inward over the one below, gradually curving to form a domed or beehive-shaped roof, all without a single drop of mortar. This is not a colonial style. It is, however, identical to the construction methods found in Neolithic tombs across Ireland, Scotland, and the Mediterranean, structures thousands of years older than the first European colonists. This architectural echo across an ocean is the first thread of a profound puzzle. The second thread is written in light. Numerous chambers are precisely aligned to celestial events. A narrow entrance tunnel might be oriented so that the light of the winter solstice sunrise pierces the darkness, illuminating a specific back wall or stone for only a few minutes each year. Others align with equinoxes or important stars. This is not the random work of a farmer storing turnips. This is the deliberate, knowledge-laden work of sky watchers. The physical technology of building them is, in theory, replicable. We understand the dry stone corbelling technique, the careful selection and placement of weight-bearing stones to create a stable, self-supporting arch. Modern masons can and have built similar structures, but what we cannot replicate, what remains utterly elusive, is the historical and cultural context. Who built these chambers and when? If they are the work of a pre-Columbian transoceanic people, as some researchers daringly suggest, it would rewrite the history of the continent. It would imply a cultural memory or a voyage that brought Neolithic building traditions across the Atlantic long before the Vikings or Columbus. Yet there is no accompanying archaeological evidence, no pottery, tools, or remains that clearly link these chambers to an ancient Old World culture. If they were built by colonial settlers, why would they adopt a complex, labor-intensive Old World ceremonial architecture, complete with astronomical alignments for simple farm storage. The purpose itself is a locked door. Were they ceremonial spaces, calendars, burial sites, or places of refuge? Each theory raises more questions than answers. The stone chambers stand as silent, sturdy enigmas. They represent a technology not of the object, but of the idea, a specific cultural blueprint that appears in the landscape without a clear history. We can copy the shape of the stones, but we cannot access the minds that arranged them, the society that needed them, or the reason that knowledge of their true purpose faded into the soil. They are a ghost in the landscape, an architecture without a documented architect, leaving us to wonder what other chapters of human movement and memory are written in stones we have simply learned to overlook. The silent stone chambers of New England pose a question of forgotten builders and lost purpose. Yet in the sands of Egypt, a different kind of question is carved directly into some of the hardest stone on earth, a question of sheer, undeniable force. Among the grand pyramids and towering obelisks, some of the most compelling evidence for a lost technology is found not in what was built, but in how it was cut. In places like the Serapeum of Saqqara, an underground necropolis for sacred bulls, archaeologists have uncovered massive granite and diorite sarcophagi, each weighing tens of tons. The precision of their flat, polished surfaces is astonishing, but it is a smaller detail that has sparked decades of intense debate. Found on unfinished blocks and in discarded drill cores are deep, cylindrical holes. To the untrained eye, they are simple holes, but to a modern engineer with a machinist's background, they are deeply puzzling, even shocking. The interior walls of these holes are not rough or irregular. They bear clear, consistent spiral grooves like the flutes on a drill bit. This is the telltale signature of a tube drill, a hollow cylinder that cuts a circular curve and leaves a solid core behind. The groove pattern, however, tells a specific story. The spacing between these spiral marks is remarkably even, indicating a consistent, rapid feed rate, meaning the drill descended into the rock at a steady, forceful pace. This presents a monumental problem for our standard understanding of ancient Egyptian technology. The official explanation is that they used copper tube drills, with workers turning them by hand or with a bow, while feeding a slurry of sand and water into the cutting area as an abrasive. The sand's quartz particles would, over immense time and effort, slowly grind away the stone. This method works in theory, and modern experiments have successfully drilled holes in granite using these reconstructed tools. But the results never quite match the ancient artifacts. The holes produced by copper and sand are shallower, with uneven, wavering grooves that reflect the inconsistent pressure of human-powered drilling. The ancient holes, by contrast, are deep, with grooves so uniform and deep-cut that they suggest a feed rate and sustained power that human muscle alone seems incapable of providing. The granite itself fights back. It is an incredibly hard, crystalline rock. To cut into it this cleanly and this deeply would require not just abrasives, but immense, unwavering downward pressure, likely measured in tons, maintained perfectly throughout the entire drilling process. How was this achieved? Some researchers point to the possibility of a mechanical advantage we have not yet considered, perhaps a weighted lever system that could apply and regulate that tremendous force. Others speculate about the abrasive compound itself. Could the Egyptians have discovered and used a harder, more effective abrasive than simple quartz sand, something like crushed corundum or even diamond dust, a material they had access to in nearby Nubia? This would explain the cutting efficiency, but not necessarily the perfectly even feed. The most controversial suggestion from a minority of engineers is that the grooves indicate a vibration or ultrasonic component to the drilling, a technology we associate with the 20th century. While this remains speculative, it highlights the core of the mystery. The evidence in the stone itself tells a story of a process that was powerful, precise, and repeatable. We can mimic the outcome, but we cannot yet replicate the elegant efficiency implied by those silent, spiral grooves. They are a direct, physical challenge left in granite, a stubborn piece of data that refuses to fit neatly into our timeline of tools. They force us to wonder if the true secret of Egyptian stoneworking lies not in mythical lost machines, but in a supremely refined, utterly practical application of physics and material science that we have yet to fully rediscover, a knowledge where immense force was not brute strength but controlled mechanical grace. The silent grooves in Egyptian granite speak of a controlled, powerful force, but what if the artifact itself, the very material, appears in a time and place where it simply should not exist? High on the Tibetan plateau, in a stark and remote region of China called Qinghai, lies a mystery that pushes the boundaries of accepted history to their absolute limit. This is the site of the Baigong Pipes. Here, on the face of Mount Baigong, rusted iron pipes of various diameters are found embedded deep within solid rock. They are not scattered loosely on the ground, but integrated into the mountain itself, with some extending into a nearby saltwater lake. Their arrangement does not appear random. Some run horizontally into the stone, while others stand vertically in what looks like a deliberate, if now crumbling, structural pattern. The pipes are composed of iron, but with a significant percentage of silicon dioxide and calcium oxide, a composition that has fueled intense debate. The location adds to the enigma. This is an uninhabited, desolate area, far from any known ancient settlement or industrial site. The mystery deepens exponentially with attempts at dating. While controversial and not widely accepted by mainstream archaeology, some tests on the pipes and surrounding materials have suggested astonishingly ancient dates, with estimates reaching back 150,000 years. If even a fraction of this age is accurate, the site becomes an earth-shattering outlier. At that point in prehistory, Homo sapiens were just beginning their journey out of Africa. The concept of smelting iron, of metallurgy itself, would not emerge for over 140,000 years. This places the pipes in a temporal void, a technological ghost in the geological machine. The primary scientific explanation is a natural one. Geologists propose that the pipes could be fossilized tree roots or other organic structures that underwent a process called iron replacement over immense periods. In this scenario, a mineral-rich water flowing through ancient root systems could have deposited iron and other minerals, eventually creating hollow, pipe-like casts within the rock as the organic material decayed. This is a known geological phenomenon that can produce surprisingly tube-like formations. The challenge to this theory lies in the specific details reported by researchers who have visited the site. The pipes exhibit a uniformity in diameter, seemingly arranged patterns, and a composition that some argue is too ordered for a purely natural process. Furthermore, the claim of manufactured features like what appear to be flanges or collars on some pipes, though heavily disputed, adds fuel to the speculative fire. The site, therefore, represents the ultimate challenge, not of replication, but of explanation within our current historical framework. To replicate the Baigong Pipes as a human-made artifact would require us to rewrite the entire narrative of human technological development. It would mean accepting that a culture, now utterly vanished without any other trace, mastered ironwork at a time when our ancestors were likely just discovering symbolic thought. This is why it stands as a profound outlier, a riddle wrapped in rust and stone. It forces a stark choice between two possibilities. Either it is a spectacular but misunderstood example of natural geology, a trick of time and minerals that mimics intelligence, or it is a fragment of a history we have not yet dared to write. Until conclusive, universally accepted dating and analysis are achieved, the pipes remain a haunting question mark on the mountain, a testament to how the natural world can sometimes craft puzzles so perfect they look like the work of forgotten hands. The stark, rusted mystery of the Baigong Pipes asks us to consider a history written in materials we do not recognize. But in the shadow of a well-known Egyptian temple, another enigma is carved not in cryptic metal, but in clear, deliberate stone. Within the Temple of Hathor at Dendera, a series of intricate bas-reliefs adorn a subterranean crypt. One panel in particular has ignited a century of speculative fire. It shows two figures, each holding what appears to be a giant, elongated bulb or vase. Inside each bulb, a snake stretches its body in a straight line from one end to the other. This serpentine form is held aloft by a pillar with a box-like object resting at its base, and a cable, depicted as a twisted rope, seems to connect the entire assembly. To a modern eye, the resemblance is startling and immediate. It looks for all the world like a diagram of an electric light bulb. The snake is the filament, the bulb is the glass enclosure, the pillar is an insulator, the box is a power source, and the cable is the wire. This interpretation, famously known as the Dendera light hypothesis, suggests the ancient Egyptians may have possessed, or at least conceptualized, a form of electrical illumination. The visual parallel to a Crookes tube, an early electrical discharge tube, is undeniably compelling. It invites a thrilling narrative of lost technological grandeur, of brightly lit pyramids and temples glowing from within. Mainstream Egyptology, however, offers a different, symbolically rich reading. Scholars identify the objects not as bulbs, but as lotus flowers, a powerful symbol of creation and rebirth in Egyptian mythology. The snake emerging from the flower is interpreted as a divine serpent, representing the god Harsomptus, and the entire scene is a cosmological depiction of the moment of creation, the serpent god bursting forth from the primordial lotus that grew in the waters of chaos. The pillar is a jed pillar symbolizing stability, and the box is likely a shrine. The twisted rope is a common artistic convention for representing air or breath. This explanation is deeply rooted in the documented religious iconography and texts found throughout the temple. So, we are presented with a fascinating standoff between two ways of seeing. One sees a possible blueprint for a forgotten device. The other sees a profound mythological allegory. The true technological mystery, however, may lie in a third, more subtle space between them. Even if we fully accept the symbolic interpretation, a provocative question remains. Why does this specific symbolic arrangement, this particular visual shorthand for a divine creative act, so perfectly mirror the components of an electrical light? A technology that would not be invented for another 2,000 years. Is this merely a breathtaking coincidence of form, where ancient spiritual symbolism accidentally prefigures modern engineering diagrams? Or could it hint at something more? Some researchers speculate that the symbol itself might have been inspired by a rare, observed natural phenomenon, like St. Elmo's fire or electrical discharge, which the priests then interpreted through their religious framework and encoded into their art. The act of replication here is not of a physical object but of a cognitive leap. We cannot substantiate the existence of ancient light bulbs because we lack the corroborating evidence, the wires, the batteries, the switches in the archaeological record. But the relief challenges us in a different way. It asks us to consider the boundary between observation and symbolism, between a culture describing the world as they spiritually understood it, and a culture possibly documenting a physical phenomenon they did not fully comprehend but could accurately depict. To replicate the knowledge that created the Dendera relief, we would need to enter the mind of the ancient priest-artist to know whether his hand was guided by ritual text alone, or by the memory of a strange, glowing serpent of light held captive in a glass vessel. That is a leap of context and intent we can never truly make, leaving the carved figures in their crypt, forever holding their silent, glowing secret just beyond the reach of our certainty. The carved figures at Dendera hold their secret in still stone, a silent question of symbolism or spark. But on a remote island in the vast Pacific, another stone secret was meant to move. Easter Island, or Rapa Nui, is defined by its moai, the nearly 900 colossal stone figures gazing inland with stern, enigmatic faces. Their creation at the Rono Raraku quarry is a marvel, but the greater puzzle lies in the journey. How did a society with no metal, no wheels, and no large animals transport these multi-ton giants across miles of rugged, undulating terrain to their final coastal platforms? Some of these statues stand over 30 feet tall and weigh more than 80 tons, the equivalent of a herd of 10 adult elephants carved from solid volcanic tuff. Oral tradition passed down through generations offers a deceptively simple answer. The ancestors said the moai walked. For centuries, this was dismissed as pure myth, a poetic explanation for the impossible. Yet in recent years, that very myth has been put to the test, transforming a legend into a tantalizing, physically plausible theory. Researchers and experimental archaeologists, inspired by local stories, devised a method using nothing but strong ropes and coordinated teams. By attaching ropes to the top and base of a concrete moai replica, a surprisingly small group can rock the statue from side to side, using its own center of gravity to pivot it forward in a slow, stuttering, but unmistakable walking gait. The visual is breathtaking, a giant stone figure seeming to lumber across the landscape under its own power, guided by human hands. This experiment proved something profound, that the oral tradition likely encoded a real, practical technique. It showed that the Rapa Nui people possessed a deep, intuitive understanding of physics, using rhythm and leverage to make the impossible seem effortless. But proving a concept with a single, smaller replica is one thing. Confidently replicating the full, efficient, and safe logistical system for the island's true giants is another challenge entirely. The walking method, while elegant, becomes exponentially more dangerous and difficult to control as the statue's size and weight increase. A misplaced rock, a slipped rope, or a mistimed pull with an 80-ton moai could mean catastrophic damage to the irreplaceable statue and grave danger to the crew. Furthermore, the terrain between the quarry and the coasts is not a flat laboratory floor. It is a chaotic landscape of hills, valleys, and uneven volcanic rock. Negotiating these obstacles with a delicately balanced, walking colossus requires a level of coordination and risk management that modern experiments have not yet scaled. This gap between plausible theory and proven, large-scale practice is where the true lost technology resides. It was not just the walking motion, but the complete cultural system that surrounded it. How were the teams organized? Who called the rhythmic chants that would synchronize the pull? How did they plan the route, preparing the ground in advance? What happened when a moai fell, as some unfinished statues along the ancient roads suggest they did? The knowledge was not merely in the ropes, but in the social fabric, the chants, the collective confidence, and the generations of learned, embodied skill that turned a perilous engineering feat into a repeatable cultural ritual. We can make a statue walk in a field, but we have not yet rebuilt the invisible framework of trust, tradition, and terrain mastery that allowed the Rapa Nui to guide their ancestors, stone by deliberate stone, across the island. Their achievement stands as a monument to human cooperation, a technology where the most crucial component was not a tool, but the united will of a community moving in perfect, patient rhythm. From the rhythmic, walking giants of Easter Island, we travel to windswept Scottish hilltops where the stones themselves bear the scars of an ancient, unimaginable heat. Scattered across Scotland and parts of Europe are the remains of Iron Age forts with a bizarre and alarming feature. Sections of their massive stone walls are not merely blackened by fire, but transformed. The very rock has been fused into a dark, glassy substance, as if a giant's blowtorch had swept across the battlements. This process is called vitrification, and it is a profound thermal mystery. To melt solid stone into glass requires a sustained, focused temperature of at least 1,100 degrees Celsius, a white-hot fury that far exceeds the heat of any ordinary bonfire or even a typical forge. These are not small, localized patches of slag. At sites like Tap O' North in Scotland or St. Suzanne in France, vast stretches of the defensive walls, sometimes several meters thick, have been vitrified into a single, solidified mass. The visual effect is startling, a brutal contrast between rough, tumbled stone and the eerie, flowing smoothness of the glass where the rock surrendered to the flame. How could Iron Age people, over 2,000 years ago, generate and control such catastrophic heat on such a monumental scale? The theories proposed are as dramatic as the sites themselves. One long-held idea suggests these forts were destroyed in a massive, ritualistic conflagration, perhaps by their own inhabitants to deny them to an enemy, or by conquerors in an act of ultimate dominance. The walls, packed with timber lacing as part of their construction, could have become a colossal, slow-burning pyre, yet experimental archaeology casts serious doubt. Modern attempts to replicate this by building stone and timber walls and setting them ablaze have produced charring, collapse, and some minor vitrification at the core, but nothing approaching the extensive, uniform glassy layers seen in the ancient forts. The timber simply burns out too quickly, unable to maintain the critical temperature for the hours required to melt granite or sandstone entirely. This failure has led to more speculative and more chilling possibilities. Could the builders have used a form of ancient science, deliberately incorporating chemical additives into the mortar or stone that acted as a flux, lowering the melting point of the rock in a controlled manner? Some researchers point to the potential use of specific plant ashes or mineral compounds known to early people. An even more controversial line of thought wonders if the heat was not general but directed. Could some lost method of focusing sunlight, or even a speculative form of chemical or electrical energy, have been applied to the walls, turning them into a kind of primitive, terrifying glaze? While these ideas venture into the realm of speculation, they highlight the core of the enigma. The purpose is as debated as the method. Was vitrification a deliberate act of defensive engineering, creating a harder, more unified wall that was stronger and more fire-resistant? This seems counterintuitive, as the process would have severely weakened the structure during its application. Was it a symbolic act, a way of ritually sealing a site, of transforming a secular fortress into a permanent, glazed monument through an ordeal of fire? The silent, glassy stone offers no easy answers. Modern engineers, with our propane torches and industrial furnaces, can certainly vitrify stone, but we cannot replicate the specific conditions that allowed Iron Age communities to achieve this effect across entire hill forts using only the materials and knowledge of their time. The vitrified forts stand not as ruins, but as monuments to a forgotten thermal art, a technology of fire so intense and so precisely applied that it turned the solid bones of the earth into flowing, frozen liquid, leaving behind a landscape of questions forged in glass and flame. The silent, glassy scars of vitrified forts are a testament to a forgotten mastery of heat. But in the stark, windswept Bolivian highlands, another site presents a puzzle of a different order, one not of fire, but of impossible cold precision. Puma Punku, part of the vast Tiwanaku complex, is not merely a collection of ancient stones. It is a landscape of geometric chaos that whispers of a technology so refined it feels alien. Here, scattered across the high-altitude plain like pieces from a giant's shattered toolkit, lie andesite and granite blocks of staggering weight, some exceeding 100 tons. Their mass is not the mystery, however, it is their form. These stones have been cut, shaped, and finished with a level of exactness that defies the accepted timeline of human tool-making. The surfaces are not merely flat, they are perfectly planar, with edges so straight and sharp they look as if they were sliced by a modern diamond saw. You find precise, right-angled notches, clean T-shaped grooves, and intricate channels cut into the hard stone with unwavering consistency. Some blocks feature drill holes that are perfectly cylindrical, with smooth, parallel walls. The most famous are the H-shaped blocks, each an identical, complex interlocking component that fits with its neighbor not just snugly, but with a precision measured in millimeters. To stand among these stones is to feel a profound cognitive dissonance. They do not look hand-worked, they look machined. The official archaeological explanation is one of immense patience and simple tools. The Tiwanaku culture, which flourished over 1,000 years ago, likely used stone hammers, abrasive sand, and water to slowly grind the rock into shape. This method, given enough time and a large enough workforce, could theoretically produce flat surfaces. But when you examine the evidence on the ground, this theory strains under the weight of its own implications. The sheer volume of perfectly cut stone, the repetition of identical complex forms, and the flawless execution across hundreds of blocks suggest not just patience, but a production system of staggering efficiency and quality control. To create these interlocking H-blocks using only pounding and abrasion, each one would need to be painstakingly matched to a master template, a process of constant measurement and adjustment that would take a team of artisans years for a single stone. Yet Puma Punku is filled with them, many seemingly prefabricated to a standard design. The drill holes present another quiet challenge. Creating a deep, perfectly round hole in granite with a handheld stone drill and sand is possible, but the hole's interior would typically show a tapered, irregular shape with a wavering pattern from the inconsistent pressure of human hands. The holes at Puma Punku, however, are reported by many researchers to be remarkably uniform in diameter from top to bottom. This suggests a drilling apparatus that applied not just rotational force, but consistent downward pressure, something more akin to a simple drill press than a handheld tool. Could the Tiwanaku have developed such a mechanical advantage? We have no archaeological evidence of it. Modern stonemasons, using traditional tools, can approximate some of the finishes, but they admit that achieving such perfection on this scale, with this hard a stone, would be a lifetime's work for a single block, let alone an entire temple complex. The stones of Puma Punku, therefore, stand as a silent argument against gradual, manual shaping. They speak of a process that was fast, repeatable, and governed by a rigorous geometric standard. This pushes us toward a humbling possibility. Perhaps the true lost technology here was not a magical tool, but a supremely organized and sophisticated industrial methodology, a forgotten school of engineering that treated hard stone not as an obstacle to be conquered through brute force, but as a material to be precision machined with a system of templates, jigs, and coordinated labor we have yet to fully comprehend. They are less like carved monuments and more like components, waiting for an instruction manual we can no longer read, leaving us to wonder if the builders of Puma Punku were not just artisans, but the ancient world's most precise and mysterious engineers. These scattered wonders are not random anomalies. When we step back and look across all 20 examples, from the Antikythera gearwork to the fused stones of Scottish forts, a series of haunting patterns begins to crystallize. The first and perhaps most profound pattern is a recurring mastery of material science. This was not a simple understanding of resources, but a deep, almost intuitive chemistry. The Romans did not just mix concrete, they engineered it to collaborate with seawater for millennia. The smiths of Damascus and Ulfberht did not just forge metal, they commanded carbon at a molecular level, weaving nanostructures into steel centuries before we had the words to describe them. This pattern suggests these cultures possessed a form of knowledge that was deeply empirical, born from generations of patient observation and refinement, a hands-on science that lived in the workshop as much as the library. A second, unmistakable pattern is the application of advanced engineering principles. The Antikythera Mechanism is pure precision mechanics, a physical model of celestial mathematics. The walls of Sacsayhuaman and the blocks of Puma Punku demonstrate a staggering command of geometry, load-bearing, and mass logistics that rivals modern civil engineering. The Nazca Lines reveal a mastery of large-scale surveying and perspective. These are not the products of trial and error alone. They are the fruits of applied intellect, of societies that could conceptualize a complex system and then mobilize the will and skill to physically manifest it, often on a breathtaking scale. Which leads to the third pattern, the monumental. The scale of ambition is a constant. It appears in the 80-ton Moai walked across Easter Island, in the multi-ton granite blocks shaped in Egypt, in the vast vitrified ramparts of an Iron Age fort. This was not merely about building big. It was about binding entire communities to a single, generational vision. The technology here was social as much as physical, a sophisticated logistics of human coordination, faith, and shared purpose that we can scarcely imagine replicating today. When these patterns are viewed together, they force a difficult but fascinating question about the nature of progress itself. Our modern story of technology is a line, a steady, upward climb from simple to complex. But these artifacts whisper a different possibility. What if advancement is not always linear? What if it can be cyclical, rising to a brilliant, localized peak and then fading away, its secrets buried by time, conflict, or simply the loss of the last master who held the knowledge? The precision of the Antikythera gearwork vanishes for over 1,000 years. The formula for Roman concrete is forgotten. The walking of the Moai becomes a myth. This points to a terrifying fragility inherent to human knowledge. A technology is not a permanent possession. It is a flame that must be continuously tended and passed hand to hand. When that chain is broken, the light goes out, and the civilization that follows must rediscover the spark all over again. So were these marvels happy accidents, flashes of genius in the dark, or were they perhaps inherited fragments from an even deeper past, from predecessors whose own story is now lost to us? The most unsettling implication of all is the quiet suggestion of civilizational resets. Our recorded history is but a thin layer atop the deep time of humanity. Is it possible that the cycle of discovery, peak, and loss has happened not once, but many times, that we are not the first to gaze at the stars with a mechanical model, or to forge a metal that defies decay, but merely the most recent? These 20 objects cease to be isolated puzzles and become something far more significant. They become potential markers, scattered breadcrumbs left behind from other journeys up the mountain of ingenuity, hinting that the path of progress may not be a straight road, but a spiral where we sometimes circle back, unaware we are walking in the footsteps of giants. From the intricate gearwork of the Antikythera Mechanism to the glassy, heat-fused stones of Scottish hill forts, a consistent truth emerges. Our journey through these 20 artifacts is more than a catalogue of ancient curiosities. It is a direct confrontation with a past brimming with a sophistication that quietly dismantles our modern assumptions of linear progress. These objects are not merely old, they are humbling. They stand as permanent questions etched in metal, stone, and glass, reminding us that human ingenuity has manifested in forms and scales we are still struggling to fully comprehend, even with all our analytical tools. Each one teaches a profound lesson in humility, asking us to look at history not as a story we have finished reading, but as a vast library where many of the most important volumes are still missing or written in languages we have yet to decode. They inspire a deep and abiding sense of wonder, not just for what has been found, but for the countless other marvels that may still lie buried, misunderstood, or simply waiting for a new perspective to reveal their secrets. Perhaps the greatest takeaway from this exploration is the realization that the story of human technology is not a simple, steady upward climb. It is a complex and often fragmented tapestry, woven with brilliant threads of discovery that sometimes appear, shine with incredible intensity, and then vanish back into the fabric of time, leaving only a faint, puzzling pattern behind. The linear narrative we comfort ourselves with, of constant improvement from primitive to advanced, is challenged by these whispers of forgotten peaks. So, what do you think lies at the heart of these mysteries? Are they the legacy of lone geniuses whose insights died with them, evidence of lost schools of knowledge, or fragments of a broader, more cyclical understanding of civilization's rise and fall? The conversation continues with you. Share your thoughts and theories in the comments below. If you enjoyed this deep dive into history's greatest puzzles, subscribe for more journeys into the unknown. And always remember, the past is not a closed book. It is an ongoing excavation, and it may hold far more secrets and far more wonder than we have ever dared to dream.